Hello, everyone. Good afternoon. Welcome to this session from my music studio. If you're wondering what the background is, I also produce music, and this is now my home office during the lockdown. So, coming from you straight there. So, hopefully, the sound is good because it should be. I am one of the founders of a company called Brain Creators. Brain Creators is a company that started as a group of friends from the University of Amsterdam who all studied artificial intelligence way back, like 20 years ago. And we sort of regrouped when AI became applicable to business problems. And that's around 2015, 2016, when the hype really started to catch on. And we thought, well, let's explore what we initially studied and see how we can apply it to companies worldwide. And that's what Brain Creators is. So we've made some changes to the company. It started out as a pure consultancy business and then moved towards something very specific, which is what we do today. And that's we deliver intelligent digital inspectors. I will explain a little bit more about that, but maybe it's just easiest to show you as a short movie because that always translates better. So have a look. Okay, so that gives you a quick impression of our business. Basically, it's about automating a human process. So, an inspector, whether it be in a factory or for infrastructure on roads or someone at an airport, they usually look at objects in the real world and assess their state. So they think, does this need replacement? Is it dirty? Does it need to be whatever? Is it broken? Is the light off? Is there a hole in the road? Etc. Etc. This is usually a lengthy process where they look at footage or they physically walk through a space and inspect it. And this part is what we automate, and we use AI in the background, but we don't really like to talk much about it anymore, although I am going to today. But that's because AI raises all sorts of expectations with people, right? It's all one big mesh of applications, whether it's natural language processing and chatbots, or whether it's numerical, so tabular data as we call it. It's your sales prediction or churn prediction, and it's computer vision. It's all of that, and just using the words artificial intelligence or machine learning confuses a lot of our prospects because, well, it could be anything related to data, basically. So we talk about digital inspectors, very focused, an application where the part of visually analyzing something and drawing a conclusion from it is automated. That's what we do, and we do this on a platform called Brain Matter that makes it very easy and fast to create new inspectors on a different domain. Today, I want to talk a little bit about what we actually mean with AI, machine learning, from our perspective, of course, and how to apply this and what the pitfalls are, where we're at with the current state of this, and where we're going in the future. Now, I hope I leave some room in the end for a couple of questions because you may have some, but bear with me. At some point, it's going a bit deep into how we do it, but it will never get too technical, and it will leave you with a thought of how to apply it for customer experience and how not to apply it. To get back to the start, what is intelligence? Well, intelligence is basically, by definition, the ability to learn something new. That could be through knowledge transfer because someone is teaching you something by showing an example, or it can be by trial and error, where you just go into the world, try some stuff, see that stuff breaks, do it differently next time, and then at some point you learn how to perform a certain task. That's basically what we call in machine learning. Difference between supervised learning and unsupervised simply where I tell you this is a road because cars can drive on it and it's flat enough and it has all kinds of properties. And unsupervised is where you just walk around and you think, well, I've seen this surface now a couple of times. It all looks alike, and apparently stuff is moving on it. This might be a road, right? And then you can confirm this by saying, yes, it's indeed a road. So intelligence is the ability to collect something new that you can apply in reality. It's a little bit more than just learning at once. There's different stages in learning. So there's basically this pyramid where on the top of creative learning, it's where human intelligence is, right? We can use all our prior knowledge and all our context to think of something new, to invent, to reinvent. This is really creative thinking, and it's creating new solutions, new knowledge. All the way at the bottom is simply memorizing. So that's what we did in school, right? We tried to learn French words and repeat them a lot until we memorized them. And the next stage is understanding. So you memorize this, but you can also replicate your memory in different situations. Then there's applying it. So knowing when to use this learned knowledge in a real life situation to actually do something. Then there's analyzing, like, how did I do this? So what actually happened? And there's evaluating. So like, okay, I did this, this happened, and then that happened. So how could I improve this? Or was it good enough in the first place? And then finally, you end up at creation, where it's inventing a rocket ship or whatever it is. Now, humans are great at this because they combine sort of their intuition with creativity, with emotion, with consciousness. Machines, by definition, are simply calculators, right? So they calculate with ones and zeros and they end up at some sort of formula, something we call an algorithm nowadays. This algorithm has similar properties as the basic versions of learning for humans. And there are some true believers who think that if we just continue on this path and add more data to our algorithms, they will reach stages where they are emotional and they are creative, etc. But there's also a whole group of people that don't believe this is the case yet. One of the founders of this theory of machine learning, basically neural networks, he was not the only one, but he's considered as one of the three founders, is Geoffrey Hinton. And Geoffrey Hinton is a very interesting character. So if you Google or you watch YouTube for him, there are some very nice interviews where he explains in common language how this came about and what he expects of it. And he still believes that machines will be capable of reaching this top level in the pyramid. He also says that for it to really advance, for machine learning as a topic to advance, we need to throw it all away and start over again. And you could add to this and start over again and start over again, because we're only halfway the pyramid right now. And we sort of avoided the top three stages where it's really about creativity, about insight, about reasoning, about large context. And my assumption is that with the current set of algorithms we have, which has fancy names such as deep learning and machine learning and computer vision, we don't have the right algorithm yet to copy human intelligence fully. Human intelligence has a way of bypassing the need for a huge amount of data and the need for a huge amount of experience by just drawing a conclusion. And for instance, you could show a kid a number sequence, which could be the area code for a phone number, but you haven't told her that. You just give her this number sequence, then you show her a longer number and you say, well, this is a phone number for a certain area. And then for every next number you show it, she will conclude that because it has the same 3-digit area code, this must also be a phone number. That's a way of reasoning in a human mind that needs to be made explicit to a machine in order to conclude this, while the human just does this very naturally. So this is one example of where the differences are. So we need to restart and start all over again with newer algorithms, with better insights. And this, of course, improves as we learn more about the human brain as well. Now, today, we're using models that we sort of improved on, but the models, the deep learning models, date back through the 1950s, 1960s. So we've been using the same theory for a long time, and maybe it's time for a change. And I think that's where the machine learning world is looking for something that has an impact, because it's a different way of machine learning compared to what we've been using for 70 years now. So where are we now? In the 80s, when I grew up, this was on the television, Michael Knight in Knight Rider with Kit, his car that did everything automatically and also had emotions, feelings, and was always there to save Michael Knight. And funny about this is that a lot of this stuff is actually present in our cars and on our bodies right now, right? So if you see, he's talking to his watch. Back then, this was nowhere to be found. Today, it's a reality. Also in the car, simple stuff like navigation and cameras looking around the car, etc. That's standard now, right? And back then, this was all a fantasy. It didn't exist. So a lot of this we already implemented, except for the creative part where Kit is reasoning about the world and actively helping Michael, driven by emotions most of the time. But this picture isn't a reality yet. So where are we now? We're at the stage where we can intelligently automate repetitive tasks. So what I mean by saying this is a repetitive task is something we perform over and over again, but requires a certain level of knowledge. We need to know what we're doing. So to make it very concrete, if you're a spam filter, you need to know what spam is and what's not. You need knowledge about the properties of spam before you can send it to the spam folder. This is one of the oldest examples of machine learning. And in our practice for the digital inspectors, you need to know what to inspect. So if you are inspecting a road for holes and cracks and everything, you need to know what the different classes by some sort of standard, which is the CROW in Europe, what this standard is and what it means and what the defects look like and the variance of it and the severity of it. All this knowledge you apply consciously or unconsciously when you assess a road if you're a road inspection. But you do the same thing over and over again. Each road looks the same to you, it just has different defects in different positions. But the task is repetitive. For a new kind of road, the task is more creative because you have to figure out what different defects types there are first. And then once you acquire this knowledge, you can keep on repeating it. Well, this is how it works with machine learning nowadays, and especially deep learning algorithms we use. We need to show them examples. A human needs to say, these are types of cracks in a road. There may be 10 and there may be 10 severities, but they look like this. And then the machine can copy this behavior and this knowledge and make it its own and generalize over it, so that if you give it a picture of a piece of road, it can automatically detect the defects it learned to identify them on the road. Moreover, it can do a form of unsupervised learning where it sees that stuff is wrong on the road that it hasn't recognized before, but it looks different. It creates a cluster of a phenomenon. And then the human can say, oh, okay, that's crack type 14. So from now on, anything you see that looks like this is crack 14. This is basically the stage where we're at. And this has applications throughout. So in language, in tabular data, but also in computer vision. Now, teaching a machine, as I mentioned, you need to show it examples. So I explained this a lot, but I found that the best way to show it is just have a movie clip and show you how this works. Well, it's a bit lengthy, so I may stop it at some point or just talk over it like I do now. It's basically creating a project in this case in our Brain Matter platform for digital inspectors specifically. You put in the data, and data in this case is images or video or whatever visual representation there is. And current algorithms, deep learning algorithms, are very data hungry. So you can't just show it 2 examples and say, well, this is what a tree looks like, good luck with it. It needs at least a couple of hundred of examples. And by examples, I mean pictures, representations, graphs, whatever, where it's clearly indicated what to look for. So if you want to find a crack in the road, this is a particular case for a road inspection, you need to define first the types, like you see here, what types of defects are there in a road, and then you need to show the machine where these defects are. So we've integrated some smart ways of pre-filtering your data, so it becomes very easy to collect all cracks like you see here or stripes in one data set and bulk label them. But this, what you're seeing now, is basically the process of labeling. So it's creating examples. It's indicating to the machine like this error class is here, and there's also one here, and there's one here. Now, this process becomes incrementally faster as you go, but it is some work, at least if you're the first one to do road inspection. Once a company has done this and we can inspect the road, you can simply copy it. And that's the power of this kind of automation. But for the first one-off, you need to do this explicitly. Now, the next step is to review. So review how good the digital inspector or how good the algorithm is actually performing. So you can teach it stuff, but you need to know when it's enough, when to stop. This has all kinds of pitfalls with something we call balance, which means if you say want to recognize two types of trees and you annotate one type of tree heavily with 1,000 examples and the other you give just 5, then there's an imbalance in the training material, an imbalance in the examples, and it won't learn accurately. So you need to have a similar set of cases for each class or each defect in this case you're trying to recognize. And then you just start testing the machine. So you say, okay, now learn from this data set and then show me what you learned. And that's actually the last stage we just saw. It's where you kind of review the results from the machine. If it's not good enough, you add more examples. It's that simple. And this is without ever encountering any technology. It's all about showing the machine your job as a human and how to perform it by example, not by explanation. That's an important nuance. So how do you apply this? Well, this is a simple example. We provide a product called ARA that's for anonymization. So a big problem, especially in Europe, is that if you use images, you can't use the people who are in them because that's a privacy concern. So first, we need to recognize humans and blur them. Now, this is one particular case. We also do full body blurring or just removing them from the background. You can have all kinds of masks, as we call it, applied, but the basic algorithm and what the machine learning does here is just simply recognize where human faces are or where human bodies are. That's the machine learning part. The blurring, the mask you see on it, the skin color mask, that's just image manipulation. It's right. If you found a face, then find the edges and put a mask on it. But the machine learning part is always the same task. It's recognizing a human face or a human body. We can teach that by showing it a lot of humans and say this is a face and this is not. And then at some certain point, a machine will generalize over this and be able to take any picture or any film and find humans in it. And then the next step is blurring it. This is what we call the perceive, decide, and respond that our digital inspectors perform. So they perceive the world through some form of visualization. They decide what phenomenon they're looking at. So they decide where the human faces are, and they take action as a response by blurring the face. This is always the paradigm for us. Now, another example related to COVID in this time, you can also teach a machine, once it's recognized humans, how to take a next step and say, okay, now recognize the distance or the cluttering between humans. This is very relevant for airports at this moment. Same principle. And what it does here is just recognize the humans, then recognize where cluttering of humans is appearing because they are close together. And then the response step is drawing these lines between them and showing the alerts when they get too close. Now, this is a very complex slide. I was considering whether I should put it in or not, but put it in anyway. This is basically the comparison between both processes, the human process on the left and the machine process on the right. So preparing a new human inspector takes having a human resource, me, going to school, getting a basic education, learning a language, learning math, then going through specialized training maybe at the college to learn about roads or to learn about airports or to learn about things going on in the factory. Then getting everything in place to acquire imaging, because for road inspection, there are cars driving around with scanners and cameras on them. You need to buy those. Then you need some sort of process. So you need guidelines, like what to look for, how to look for them. You need standards. What are the defect classes we can expect? And procedures. So what should happen when you find a specific defect class? Should you plan maintenance or repair it straight away, etc.? Then for a junior employee, you start working at the company as a junior and you need to be trained on the job to become a senior. And then once you are, you still continue to learn on the job. And you perform this repetitive task of looking at road surface by perceiving, deciding, and responding all the time. Now, for the machine, this is kind of similar, but you start with the pre-trained algorithms, the deep learning concept. So because we have built a number of digital inspectors, there's already the basic level of knowledge in those models that you would get from school. Then you start teaching the machine from a junior to a senior. And because it's a machine and it can process much more data and these examples in very little time, this goes much quicker. It doesn't take years. It takes a couple of months to train a new inspector from scratch. And then once on the job, it still continues to learn because it sees more visualizations, it sees more data, and it's supervised by a human in the end. So it's also corrected and it learns from that. And then the perceive, decide, respond is exactly the same, but automatic. So faster, day and night, never distracted, never sick, no holidays, etc., etc. So those are the benefits of digital inspectors. It goes a lot faster. It's a lot more consistent because the machine isn't distracted by its own creativity for now. So it always does the same. And for the human, another big part is that humans tend to leave or get sick or retire or whatever. So this is also a way to secure this knowledge in your system. Okay, that's for the very long slide. So a couple of examples for customer experience and AI in customer experience. I just took some and I hope can relate my previous story to this. So on the left, it's a chatbot, and it's a chatbot that leaves you with little options. So for repeatability, if I'm coming to this specific site, and maybe it's an insurance company or it's something else, it's a train company in this case, I have a specific purpose. So it's predictable for this chatbot what I'm here for. So it can already suggest to me what I could be looking for. And that's a very focused conversation that's very repetitive. It's a repetitive task and it makes it very concrete. The opposite is on the right. So on the right is an open chatbot where humans expect it to behave like a human. So on any topic, it will have any conversation. And if you understood anything of the story I explained, that is very hard because that goes all the way to the top of the pyramid. It goes to creative responses. And most chatbots just have a script with a little bit of sugar AI on top. So in this case, you don't get really far with this chatbot. Another example, which looks a lot cooler, is this one. It's a company that joined us to the CES mission last year in Las Vegas. There's always a Dutch delegation going there with like showcases. And these guys do a automated try-on of stuff. They now have a huge contract with Adidas. It's trying on shoes. So you select a shoe and you see it's not perfect yet, but it's getting better every time. And the AI in this is simply recognizing where the shoe should be and how it should be tilted. And then the rest is just image manipulation, Photoshop kind of stuff. But it's not only chatbots. I hear a lot of people saying in customer experience, oh, AI is very useful in chatbots, but it's also this kind of customer experience, trying on stuff. And we work with a big retail company to do this for clothing, give better suggestions, etc., etc. But the basic thing is this is predictable. It's always the same. So human feet usually look the same. So you can teach a machine to recognize the pattern of finding the human feet, and then it's a repetitive task all over again. So if you're considering to do something with AI in your customer experience, forget about the top of the pyramid. Forget about the magic of the machine thinking for itself. Look for the stuff that's repetitive and that adds value, and that's where you can use and apply AI. And it's basically picking your battles, right? So it's not at the level of human intelligence yet. So you can't expect a chatbot at bol.com that knows how to find the right category of products for you and sort of trick you into buying something or put it in your basket, whatever. That's in its domain. And maybe the programmers had some fun with it and also included a conversation about the weather. But you certainly can't have a human-like conversation where you switch context all the time and you ask it difficult questions. So it's not at that level yet, but it is already very helpful because it saves a company like Bol a lot of time to have repetitively the same conversation with a lot of people over and over again. Now, it works best or on repetitive tasks as part of a bigger process. And what I mean by this is very real for us. Concrete example, we went to a gemeente, which is a municipality in the Netherlands, and we go in and we say, well, we can do these visual inspections. Now, the part where humans can actually see it and assess it visually is what we can automate. But there's usually a hidden layer where humans go a bit further and say, well, okay, so take, for example, the lighting poles on the streets. We want to recognize them. We want to recognize the type. We want to see if they are bent or straight up. But we also want to know the electrical connection or the light bulb type or the brightness of the light or et cetera, et cetera. And these are all things that aren't clearly visible to the human eye at first sight. So if we get pictures taken by a car on the street of lighting poles, we can tell what's in the electrical connection because we can see it. But this is a jump humans often make. So okay, so if it's capable of that, it will also be capable of this really smart thing. That's not the case. The part where we recognize which types of poles are where and put them on a geo map because we know the GPS location of the car, that's very doable. The part where magic happens and it does more than the human eye can see, impossible. So when you specify a process in customer experience and you want to include AI to automate a repetitive task, clearly segment it as the part to be automated by a machine and the part that remains on the human side or needs a different system. Don't go for full automation of everything and expect AI to handle all of that. Another important point, it augments human performance. The most successful chatbots, but also the most successful inspectors or any AI application has a human supervising it. So once you get stuck in a chatbot for an insurance company, you are redirected to a human who can help you on the more complex stuff. Once you've recognized defects on the road and you want to add some extra properties, like, okay, maybe this segment of the road is in really bad state and we should prioritize maintenance, but then we need to agree with the maintenance company that we do it segmented, etc. That's left to the human. That's not in the AI. So it augments the performance of the human. They can simply do more of this in less time because part of the process is automated, but it's not like you give it to a machine and magic will happen. So use it wisely, and that's the end of this presentation for me. If you have further questions, feel free to reach out, and I'll happily answer them. And we have demos to show you how these digital inspectors work in practice. So don't hesitate to contact me if you want to know more. And thank you for your attention.
Hey, thanks, Jasper, for sharing your insights. And we're looking at a couple of questions, I think, at this stage. Yeah, and there's one comment as well by Dean Smith. Some amazing stuff in AI. Great, Jasper. So a good application for car repair companies to get pictures of a car that is damaged and using the AI to define the extent of damage, I think, into parts of cost and provide quote remotely. Really interesting. Thank you.
My pleasure.
Yeah. Yeah. So the question, I guess, is essentially, a lot of people get confused by just using chatbots and say they have become AI proficient, we've spoken about this earlier as well, which is more to do with trying to solve business problems. Where should they start on their journey to become a true AI company, a non-technical technology company?
It's a good question. I think in the AI hype that we've seen over the past 5 years, it has become a goal to become a AI company. I don't think that should be your goal. Your goal should be to improve whatever your business is doing by leveraging whatever technology can offer. And AI now is one out of a set of technologies that could speed up or improve your business. So in a very concrete case of this road inspection example, if you can perform these inspections 10 times faster and you're a road inspection company, you can handle 10 times as many customers as you could. So it accelerates your business. And the goal should be that. It should be to accelerate your business at some point and not to be a business that applies AI to something. So if you have a customer service center and there are 50 representatives in there chatting away all day, you could maybe handle 10 times more chats if you would automate the first part of the chat with a chatbot. And that's, I think, the way you should look at it. So look at your business processes, look for repetitive tasks that are not automated yet and that also have value, right? So there's also a subset of tasks that aren't automated, but at the same time aren't that costly or aren't that important, and you don't have to automate them. But if you see stuff happening all over again every time and it's handled by humans, that's usually a good place for applying some sort of automation. And then intelligent automation in any form is a new way of improving this, or tackling new issues that couldn't be tackled before. But that should be your goal. So accelerating whatever you do in your business, not necessarily wanting to apply AI, if that
Yeah, I
makes
think that's
sense.
a great answer, Jasper. I was just looking at the watch. We are slightly behind schedule, but I would ask the audience members to continue posting your questions, comments, and also we have a networking session a bit later when people can join you and continue the conversation. So, with that, I would like to thank you again, Jasper. A
You're welcome.
round of virtual applause for you, and we will see you during the roundtable discussions.
Thanks, everyone. See you later.